Good morning. Today we are working on exponential functions, how to write equations from graphs, and then we're going to take that graph and do key features such as domain, range, and asymptotes. So the equation we're going to write today is going to be in the form of y equals ab raised to the x power. A is going to stand for the y-intercept, that is your starting point, and b is your factor of growth or decay. If it's a growth, your b value is going to come out to greater than 1, and if it's a decay, your number is going to come out to between 0 and 1. So we're going to start off by looking for our y value. My y-intercept is that number right there, so we're going to go ahead and count, and we count 1, 2, 3, 4, 5, 6, 7, 8, okay? So 8 is going to be my a value. That's where this graph is starting. In order to find b, I'm going to actually make a table with the values that I can see. So at 0, it's 8. At 1, it's 4. At 2, it's 2. And at 3, it's 1. So that's enough actually to get my data from that. So what we're going to do is we're going to divide y2 divided by y1 repeatedly. Now, the numbers, when I say y2 and y1, it doesn't really matter. What I'm going to do is I'm going to take the second term divided by the first term. So then if I'm using these two, I'm going to do the second term divided by the first term. And then when I use these two, I'm going to do second term divided by first term just to check. So I'm going to do 4 divided by 8, and I get 1/2. I'm going to do 2 divided by 4, and I get 1/2. Doing this repeatedly, I should get the same number if it has a common ratio. My common ratio is my b value. So my b value is 1/2. 1/2 means that it's a decay. The graph is going down forever. So my final equation, my function is f of x equals a times b raised to the x power. Now we're going to look at domain. Domain for exponentials. Most problems, if there's no limitations, if it's not real world, my domain is all real numbers. You may also see this written like a double R, okay? My range is asking for my y value. How low is the graph going and how high is the graph going? So this graph is actually, the lowest point it's going to go is right here, and it's going to get very, very close to x, but never going to touch it. So when we look at my range, my lowest y value is going to be 0. And because it's going to go up and up forever, it's 0 to infinity. We can write that a couple different ways, but we're just going to go ahead and write that y has to be greater than 0. Notice my y values, none of them are negative. My y values are all positive, and by y values, we're looking at the y-axis. Okay, so there's my range. Okay, so let's try this again. I have a graph here. We're going to start with finding our y-intercept. So my y-intercept is my starting point. That number is a 3. So my ordered pair is 0, 3. Now for this, you want to make sure you go in order. So we're going to look for 1 next. 1, 6. Okay. 2, and we're going to count 2, and it looks like it goes through right here. So that's a 12. I don't have any numbers in my graph that are perfectly on the line, so that's all I'm going to use. Again, we're going to divide y2 divided by y1. 6 over 3 equals 2. 12 over 6 equals 2. Because I have a common ratio, that 2 is my b value, because b is my common ratio. So my function is f of x equals a is 3 times 2 raised to the x power. My domain, because there is no restrictions, is all real numbers. My range, what's the lowest my graph is going? And we're looking at the y-axis. This graph is getting very, very close to when y equals 0, but it's never going to get there. So my range is y is greater than 0. And it's greater than because it's never going to touch 0. Well, why is it never going to touch 0? Because it's an asymptote. When we deal with exponentials, any number I put in the value of x, so this number right here, if I put anything in there, if I can put 0, I can put 1 million, I can put negative 1 million. Anything I put there is never going to make this value 0. So this graph is never ever going to touch 0. It can get very, very close to it, but never going to touch it. Okay? Now go ahead and pause this video and try this one on your own. Hopefully this matches with the information that you got. So I started with my y-intercept, which was 4. That's my starting value. That's my A value. And I made my table. I had 0, 4, 1, 2, 2, 1. I wasn't too sure on the next one, so I just stopped right there and I found my pattern. Remember, we do the second term divided by the first term. Second term divided by the first term. A 1/2 tells me that this was a decay. Okay, and decay means the graph is going down forever, and the graph is going down forever. Domain is all real numbers. My range is y is greater than 0 because it has an asymptote at y equals 0. We have one more. Okay, again, you're going to try this one on your own. Okay. Hopefully you found all of these answers. So I started with my y-intercept, which is my starting value. That was a 1, so I wrote that here. Then I made my table. Now, I know when we worked on tables before, there was some confusion, which is why this time I'm showing the division here, because you always take the second one divided by the first one. Okay? If we hadn't done that, I think somebody asked why do we have to divide that way? Well, had I done 1 over 4, 1 over 4 would have been a decay, and as you can see, this graph is not a decay. My range is y is greater than 0, and my asymptote is y equals 0. Now remember, everything we did today had no transformations on it, so transformations would shift a lot of this, but hopefully this helped you guys writing equations from tables and graphs, because those graphs always come back to the tables. Well, if you liked this video at all, if it helped you in any way, please give it a thumbs up. And if you want to subscribe to my channel, I will be posting more educational videos.